Attendees are in listen-only mode.
Hello, everyone. Welcome to today's webinar, Deep Energy Retrofits, Getting to Zero Net Energy. My name is Connie Umphris, Communications Manager for New Buildings Institute. Before we begin, I have a couple housekeeping things to tell you about. First, you are muted and we cannot hear you. This helps keep the background noise down so that everyone can better hear the speakers. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you are having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in this dashboard to let us know and we will help you as we go. We will take questions at the end of the webinar, but you can ask questions anytime during the session using that same question pane. At the end of the webinar, you will be given the opportunity to take a short survey. During the survey, you'll be able to enter your AIA number to receive continuing education credits for this webinar. Our speakers today are Michael Blaney and Pooja Vohra of National Grid and Sean Denniston from New Buildings Institute. Pooja Vohra is a principal analyst in National Grid's Commercial Industrial Energy Efficiency Program Strategy Group. She is responsible for developing programs and strategies for National Grid's commercial industrial portfolio of energy efficiency programs. In the last 5 years at National Grid, she worked on developing a codes education program and enhanced new construction program offering, and currently is working towards developing a zero energy building pilot initiative. She has a bachelor's degree in architecture and a master's in energy and climate. Sean Denniston earned his bachelor's degree in architecture at the University of Oregon and a master's in historic preservation at the University of Pennsylvania. Sean's work at New Buildings Institute includes analysis and review of data relative to commercial building energy performance and prediction, code and energy program effectiveness, and energy technologies. He also does research and review of commercial building design practices and energy and green technologies, including application, cost, savings and reliability, preparing analysis and graphics on commercial building energy use. Michael Blaney is a senior specialist on the marketing and customer experience team at National Grid. He is a chemical engineer who has over 20 years experience designing and delivering instrumentation system solutions to energy-intensive industries such as power generation, iron and steel, oil and gas, and pulp and paper domestically and internationally. He has also served in a business development role with Sensata Technologies, focusing on new clean diesel engine technology application in non-road vehicle and propulsion markets. Michael?
Okay, good morning. Thank you, Connie, and welcome everyone. Thank you for attending with us today. Just a quick note about National Grid. We are an electric and gas utility. You can see our footprint map here. We cover basically from Massachusetts, Cape Cod, as far west as Buffalo, and we serve both electric and gas. In downstate New York, Metro New York City, really Brooklyn, Queens, Staten Island, and Long Island, we have gas-only service. That is a big area for us as well. So next slide, please, Sean. Great. So at National Grid, we have about 10,000 employees in the field every day, and safety is a top priority for us. So we start every meeting with a safety moment. So as you know, the summer's here, the lawnmowers are out, and there's a note here just about safety with lawn equipment, and whether it's a lawnmower, a weed whacker, or other tool, power tool used in the yard. There are a lot of accidents with these tools. As you can see, 253,000 in 2010 is the latest data I could gather, but that's a large number. So, be careful, follow the manufacturer's recommendations, read the manual thoroughly, always wear safety gear, including sturdy work shoes, eye protection, long pants and gloves, also hearing protection for those that are running the lawnmowers and stuff. Those things are pretty noisy. Be careful adding fuel, and have pets and children stay in the house when you're out running that machinery around. It's hard to see them when you're focused on the machinery, and certainly you can't hear them when it's running. So that's it, and thank you. Next slide, please, Sean.
All right, thank you, Michael. So
all right.
The New Buildings Institute is a nonprofit working in energy efficiency in commercial buildings, redefining what's possible in the built environment. And we do this through what we call the virtuous cycle. We begin with thought leadership and take that to do fundamental research into energy efficiency. We turn that research into solutions and move that into the market and the vision for the future. With market penetration, we're able to move those ideas into codes and policy, and then we start all over again. Since this webinar is eligible for AIA continuing education credits, we have a couple of standard pieces that to make you aware New Buildings Institute is the provider today, and Sean Denniston, me, is your instructor. Of course, this is registered with AIA, and this is the course description that you saw when the announcement went out. I don't think we need to read it to you, or the learning objectives, but once you go through this webinar, you'll be able to submit your AIA member number, like Connie said, and be able to get credits for this presentation. Now, this is the third part in our three-part series on deep energy retrofits, getting to zero net energy. But these are really all connected topics. We'd like to take a few moments to go through parts 1 and 2 and what we covered in those webinars. Part 1 was on vision, goals, and process. And we started with a very basic question of what is a deep energy retrofit. A lot of times people have the idea that it's doing specific measures. But for the purpose of these webinars, we are really talking about a deep energy retrofit being one that saves at least 30% in energy performance. We also talked about the steps to getting to a deep energy retrofit, that it's a matter of assessing the building, setting goals for performance, scoping the measures that are going to be included, implementing those measures, and then operating the building. In the first webinar, we really focused heavily on assessing the building and setting the goals. And so that means starting with looking at the building. Very basically, benchmarking, as simple as looking at the utility bills, entering them into a tool like Portfolio Manager. But looking beyond benchmarking to contextualize the data, to give you an idea, what does that EOI mean? Is it a good one? Is it a bad one? Using tools like the ZEPI scale or the Energy IQ from ASHRAE or an Energy Star scale or another way to contextualize the data and get understanding about it. We talked about using remote analysis tools like First View to take that data and use it to get insights into the building before you ever go to the building and start looking at it in depth. Not only so that you can get insights into things that you may not be able to see, but also so that when you do go to the building to do an audit, that you can be well informed and you know what to look at. Tools like this use simple information about the building and basic energy data to really give deep insights into how that building is performing. And of course, auditing, whether it's a level 1, level 2, or level 3 audit, it's important to go to the building and examine it and take a good close look at it. We also talked about the building life cycle opportunities, that when you assess the building about your opportunities to do a deep energy retrofit, it's important to understand that a building has a life cycle to it, that it's going to see major renovations every 30 to 50 years. It's going to see HVAC replacements every 15 to 20 years, lighting retrofits every 5 to 7 years, lease renewals every 2 to 5 years. And then of course there are the real estate transactions like sale or when a new tenant moves in, which sometimes aligns with a new a lease expiring, but sometimes they'll stay for a couple of cycles. All of these create opportunities to trigger a deep energy retrofit. And this is part of assessing the building. Are these opportunities there? We also talked about setting goals and the difference between a % improvement or an absolute goal. This is the Boston City Hall that we talked about in the first webinar. And a 30% improvement might mean just going from one place to another. But you could also talk about just doing an absolute goal, that you're shooting for performance that's equivalent to new construction or to one of the Architecture 2030 goals. We also talked about using measure effectiveness as a way to set goals. You could say that you're going to do all measures that meet a specific criteria. And traditionally, that has meant looking at simple payback, but we also talked about looking at more comprehensive metrics than something as basic as simple payback. Something like internal rate of return, which puts the savings in the context of an investment, which is something that the business side of a building owner is going to understand better. And then you'd be able to look at that and say, well, we're going to do everything, say, with this level of an internal payback. And this can be a way to set the goals for the building, to target measures that have a certain level of effectiveness. In the second part of this webinar series, we talked about best practices in technologies and strategies. So really these next two steps and these 5 steps that we identified, scoping the measures and implementing the measures. We talked about the nearly universal measures, the measures that are going to show up in most, if not all, deep energy retrofits, whether that's reducing infiltration into the building, doing control upgrades to the building, and retro commissioning. We also talked about the importance of going beyond code. One important reason to go beyond code is that this is your opportunity to make an intervention in the building, so it's important to go as far as possible. But another very important reason for going beyond code is that the utilities, like National Grid, that's all that they can incentivize. So the utilities are out there with incentives and at times technical assistance to help you get to these goals, but you have to go beyond code to be eligible for those programs. We also talked about matching the strengths and weaknesses of a building, about looking at a building and seeing where the opportunities for good performance are, and not just looking at the building as a bunch of problems to solve. So things like lots of windows can be seen as poor performing windows, but it's also an opportunity for daylighting and natural ventilation, and having this way to look at the building. And we also talked about compounding opportunities, and by this we mean using your retrofit as an opportunity to achieve other goals in the building that might not have anything to do with energy. And to illustrate that, we talked about the Edith Stein building, where they used improvements in the energy performance of the building, improvements in the envelope and in the system selection in the HVAC system to actually downsize the HVAC significantly, and they were able to free up most of the penthouse mechanical room. And in doing so, they were able to free up tremendous additional space within the building, and it's the penthouse space, so it's actually the most valuable space in the building that they were able to open up. Retrofits can create these sorts of opportunities to be shared with the owner. And then we talked about implementing the measures and how there's a difference between different market segments, between the commercial real estate market or the MUSH market, the municipal, university, school, and hospital market that's more institutionally driven, and how these have an impact on what measures you might choose, but also how you might set up your deep energy retrofit to actually accomplish those goals. And finally, we talked about some common deep energy retrofit pitfalls that can happen, damage to the building that can actually be created, oftentimes by insulation, but by other decisions, and the importance of looking at the measures that you implement and thinking about the consequences for how the building actually operates. Which brings us to part 3, which is getting to zero net energy. And at the very beginning of this, we asked the question of what's a deep energy retrofit. And so we should ask the question of what is zero net energy? For the purposes of this webinar, we're going to define it just a little bit vaguely. A zero net energy is an ultra-efficient building that generates as much energy as it consumes annually. And sometimes this is called a net zero energy building. Now, the reason we're being a little bit vague is because there are a lot of definitions of zero net energy. What kind of energy use annually? Are we talking about source, site, time-dependent valuation? Is there a place for on-site combustibles? Is it a matter of peak that's being encouraged and accounted for as well? What about greenhouse gas emissions? Right now, this is still a topic that is in flux about what is hard and fast, very technical definition of zero net energy. But they all get at this basic idea, producing as much energy as the building consumes. And that's what we're going to go for with this. And there's a very handy reference out there. This is the New Buildings Institute Getting to Zero Buildings database. This is the largest database in the country of zero net energy, near zero net energy buildings as well. And we have both buildings that have been verified as zero net energy and buildings that are operating right now to see how close that they got. And this is a tremendous resource with lots of case studies and information about how other buildings have gotten to zero net energy. And it's easy to think, zero net energy, this is the realm of new construction, but we're no longer in the trailblazer era of zero net energy. And just in our database, we see that 24% of the buildings are retrofits, are major renovations. And so we know that it's possible. That which exists must be possible. It's something that our technical director, Mark Frankel, likes to say. He doesn't claim credit for it, but he certainly likes to say it a lot. And so we've seen that these deep energy retrofits can hit zero net energy. It's just a matter of finding out if you've got a good opportunity and then making your way there. Our database shows us the average performance, what we see of how most of these buildings are getting to zero net energy, how much energy they're consuming. And this is a very good guideline as we're looking at additional projects about shooting for zero net energy. So this is all the buildings that were in the database at a certain point, and if we look at the just over 90 EUI, that's the average for commercial buildings from the 2003 Commercial Building Survey of Energy Consumption, the CBECS. And we can see that we have a high concentration in this band of EUIs for commercial buildings, regardless of what kind of commercial building. And the average EUI is somewhere around 21 in this cadre of buildings, which means that that's a good basic goal to keep in mind. If you're going for zero net energy, then that's the range of EUI that you're looking for. But you need to look at it specifically for your building to know if maybe you can get away with a little bit higher, or maybe you need to go a little bit lower. Maybe you have a lot of roof area to work with for renewables. Maybe you don't have very much roof area. Maybe you have some site area to implement some ground-mounted PVs. These are important considerations that, while this gives a good basic idea of what you're searching for, you have to do that assessment of your building to see what you need to do for that building to hit zero net energy. And there are differences between a standard deep energy retrofit and a zero net energy deep energy retrofit. One of the biggest ones is what we talked about earlier. That in a deep energy retrofit, you might be just looking to get to that 30% improvement, which means in this case going from 122 EUI to 85 EUI. But if you want to get to zero net energy, it's not a matter of percent improvement. It's a matter of an absolute goal. And so if we're going to take this building, the Boston City Hall, to zero net energy, it means that we're shooting for a specific EUI. And there's a good chance that it's somewhere around 25. It might be a little bit higher, it might be a little bit lower when someone does the actual analysis of this building and just doesn't use it as an example. It means that it's going to meet the 2015 target for the 2030 challenge. But it's also going to mean that it's an 80% reduction for this building. And the assessment will let you know whether or not that's possible. Another difference is that in a standard DER, you might be able to get away with simple tools like the remote analysis, like using the feedback from your audits and the most likely measures to hit that 30%. You might be able to do it without doing more advanced analysis. But with a Z&E DER, whether or not it's 30% or 75% that it takes to get you there, you're almost certainly going to need to do energy modeling. Because zero net energy requires a high level of integration of all the systems. And this isn't just the active systems like HVAC and lighting and service hot water, but also integration of those systems with things like the building envelope, and further integration of all of those with the operations of the building, with the users of the building. And that's the sort of thing that we're at the point right now that it really takes modeling to get there. So this is probably going to be a part of any zero net energy, deep energy retrofit. And just like in the first episode, we asked the question, you've got a building, so to deep energy retrofit or not to deep energy retrofit? That's the question. And it's the same with Z&E. When you have a particular project in front of you, it's important to ask that question, is this a good candidate for Z&E when we consider all of these things that come in the assessment? The technology that's available and cost effectiveness right now, the owners, the market position, where we are in the life cycle of the building, all these things will impact the decision about whether it's a good time to go to Z&E with this building. It might not be now, it might need to wait until the future. So if you have a building, how do you ask that question? How do you make that assessment? Is this a good time for this building to go Z&E? And even though all of these buildings are from our database, so we know what we got there, well, how do you answer that question? Well, you can look at something like our database, and you can look through it for buildings that are similar in size to your building, a similar climate, similar use, similar shape, similar envelope characteristics. You can look for buildings that have already gotten to ZNE that are similar to yours, and that can give you a cue as to whether or not your building has the potential to get to ZNE. Our research into ZNE has also revealed that there are a set of measures that show up over and over. It's not necessarily that these are measures that are going to be in every ZNE project. It's not that your ZNE project has to have these, but these are the measures that we frequently see, and they're very common. And so you can look at a list like this and ask yourself whether or not the building that you're working on is compatible with measures like these. Can you implement a ground source heat pump? Can you do advanced ventilation, whether we're talking about natural ventilation or dedicated outdoor air systems, demand control ventilation, or even energy recovery? Can you make that retrofit to a highly efficient thermal envelope, or do you already have a highly efficient thermal envelope? Is the building orientation and glazing ratio, the window-to-wall ratio, is that compatible with hitting these very high levels of performance? Can you control the solar gain? Do you have good access to daylighting? Can you implement the controls? Is there an energy management system, or is that something that you can retrofit in there? There's an opportunity for building dashboards, which should really be able to make it into any building. Do you have the opportunity for radiant heating and cooling? Do you have a setup where you can implement plug load reductions? And are there other energy recovery systems that you can implement, whether that's service hot water or process energy recovery? And so if we're looking at some of these buildings, this is the Oak Ridge National Laboratory office building, and they have the opportunity to upgrade the envelope. They actually went from R5 to R23, and for those architects out there, you know that that's a pretty big jump for roof insulation in a flat roof like this. But it's not impossible. It's a matter of timing, and maybe it's time to replace the roof anyway. Or we can look at this project, which is the Bacon Street offices of Hannah Gabriel Wells, and we see good daylighting potential. Or we can look at this project, the Camden Friends Meeting Social Hall, and they were able to implement ground source heat pump because they had the area and they had ground that was suitable. And although it might be surprising, and this is the DPR San Diego office, it actually had the potential to implement natural ventilation. It may not look like it from this skin, but they were able to implement operable windows so that they were able to integrate natural ventilation into the space conditioning strategy. But you can also look at the body of ZNE projects out there. And the simple reality is ZNE has focused on a couple of building types at this point. And so education, K-12, office, and even higher education, we have seen a lot of projects in these building types. And so it's a well-trodden path where there are lots of examples that you can follow, and where a lot of the problems and the technology, a lot of problems have already been worked out, and a lot of the technologies already exist. And so if your project is one of these types, you have a better chance of being able to get to that ZNE goal. We talked about the life cycle opportunities earlier, and the reality is that oftentimes it's messy. You're not ready to do more than one thing at the same time. But if we're going to get to that ZNE potential, it might be looking for an opportunity where the life cycle opportunities are coming together, or where they can be brought together through some reason, or where the project is willing to tolerate bringing them together a little bit more. There is always greater opportunity to make changes when a building component is near the end of its life cycle. And this is a good time to talk about the importance of the zero net energy loading order. Just like you might tell your kids that you got to eat your veggies before you can have your dessert. It's important in ZNE to focus on energy efficiency, not just insulation, but the full gamut of energy efficiency before you do your PV. Because to a large extent, many of those energy efficiency measures are still more cost effective than PV. Even though the cost of PV keeps coming down, it's important to do all of your cost effective energy efficiency first, especially in situations where you may have limited opportunity to introduce renewables to your site. You need to make that space that they take up as small as possible because you may only have a certain amount of space that you can use. And also when you're looking at identifying good Z&E opportunities, sometimes it's not about the building at all. Sometimes it's about the owners and their motivation. So this is the Eco Center at Heron's Head Park out of the database. And so we have a very ideological owner where Z&E fits into the whole purpose for this building to exist. This is the Bushnell branch of the Suncoast Credit Union. And Suncoast Credit Union, a small regional credit union series of branches, has made the institutional commitment to sustainability. It's important to that organization. And so they also have institutional mandates about energy efficiency. This is something that you'll find very commonly in institutions like schools and municipalities and states. And they are therefore motivated to get to zero net energy. And there's the simple reality of green market competition. And this is going to make a bigger difference in some areas than others, but we're seeing more and more Z&E buildings. It's getting greater market penetration, and we're also seeing a greater emphasis on green through standards such as LEED and the Living Building Challenge. And so as the new construction market becomes more dominated by these green buildings, that they're using their green designation as a way to improve their marketability, well, that makes doing Z&E and other green retrofits of buildings more viable because the market demands that sort of thing. And so we're going to see it maybe more in cities like New York City and Boston, but as it grows, it's going to reach all of the locations that you'll be doing work in. And as you can see, we have Z&E buildings in most of the cities, most of the states in the Union, and a bunch of areas of Canada as well. So it's something that is really everywhere and is becoming more and more prevalent. And the reality is that the cost of Z&E is going down as these technologies get more and more affordable, and as the code baseline comes up more and more. The difference between a code building and a Z&E building is coming at a smaller and smaller cost premium. So this study by NREL shows that there is mounting evidence that zero energy can, in many cases, be achieved within typical construction budgets. And in our database, we actually have a handful of buildings that have achieved zero net energy at the same kinds of cost per square foot that you see from conventional construction. And the reality is that when you look at more comprehensive standards of costs and cost return, like internal rate of return, you can see a more comprehensive picture. But you can go even a step further to something like life cycle cost analysis, where you don't just look at the first costs, but you look at all of the costs that are involved in owning and operating a building, the utility costs, the ongoing maintenance, the repair and replacement costs. And then you look at the residual value that's there at the end of that building's life cycle. And the life cycle cost takes all of those, and instead of looking at them as something in the future which may or may not exist, it moves them all so that you think about the value of all of those now. And net present value is something that's very common within the business world. And so this is another one of those things that can be taken to the business side of the owners of buildings to help make the case for zero net energy. But there are more than just energy benefits to Z&E. This is a great little question and answer from our hosts, National Grid, asking that question about, well, what are some of those non-utility benefits? And the reality is there are studies that show that in green and energy efficient buildings that there are positive impacts on productivity, whether this means greater sales, greater office environment productivity, or greater test score productivity out of schools, positive impacts on the health of the occupants, positive impacts on absenteeism. So studies that have actually found a lower level of absenteeism in these sorts of buildings. Improvements to safety. The reality is that a zero net energy requires greater attention to detail, which means there's going to be greater attention to all aspects of the building, including those aspects that could create a hazard to the occupants. And that there's a positive impact on maintenance for the same reason, that because of this level of scrutiny that Z&E requires, the level of maintenance, the degradation due to maintenance is actually alleviated. And this is a PDF that will be, it's not available online right now, but if you want it, just let us know, and we might even be able to include it in the after webinar mailing. It has lots of great references to specific studies on these issues. An important element of getting to zero net energy in your deep energy retrofit is looking at the way that you put your team together. In the traditional project delivery team, you see something like this, with the owner on top. You go down one branch and there's the design team and there's all the design consultants. You go down another branch and there's the contractor team and there's all the subcontractors. And there are all these opportunities for miscommunication and for siloing and for things to get out of sync. To get to Z&E, because all the pieces of the building have to be so well integrated with each other, that means that the team needs to be well integrated with each other. Which brings us to the integrated project delivery team. This is something that's been getting a lot of play in the last 5 or 10 years in the architecture community, the idea of integrated project delivery, where the owner, the contractor team, and the design team are all communicating with each other. They're all working with each other, and it's not just this static handoff process. And so we can look at how that might actually look in a specific project. This is the Ideas Z2 or Z squared design facility. They are an architecture firm. This is in the Getting to Zero database. And as early as schematic design, they had, of course, the owner and architect involved, and the mechanical engineer, which is not involved at the schematic design phase in a surprising number of projects. But they also had a radiant system design build contractor involved. They had the electrical engineer. They had, of course, a structural engineer, but they even had the contractor doing cost estimation all the way up at the schematic phase of design, allowing all of these concerns to be integrated with each other and decreasing the chances that some of these important zero net energy features might be eliminated later through value engineering. And this also has an impact on how modeling is done. We talked earlier about how zero net energy means that very likely, almost certainly, you're going to have to be doing energy modeling in your building. And often in projects, if we're honest, that comes sometime after or at the tail end of design development, right before construction documents. A lot of times energy modeling is really just done for code compliance, but in a zero net energy building and a zero net energy project, that's not going to work. You're going to have to move that up. It needs to be part of schematic design, maybe even as early as conceptual design in a building. But it also means looking beyond the traditional modeling softwares like Energy Quest and Energy Plus. It means looking to, these sorts of Appiday and Sephora, which are programs that allow you to do iterations of energy impact so that the energy impact can be part of the iterative design process early on. They're meant to be powerful, they're meant to be very easy to use, and they're meant to be very rapid. So they may not, or they may, depending on your jurisdiction, be able to develop a model that you can use for your code compliance, but these are important design tools. And it also means that you might have to look even beyond tools like these to tools like Radiance and Gaia Geothermal and a whole slew of other design tools that can help you design the specific applications, things like daylighting and ground source heat pump in these two cases, but also natural ventilation, passive solar, all these sorts of measures that can be a part of zero net energy that a lot of the traditional energy modeling programs either don't do at all or don't do as well as you need to when you're really looking to get at a good hard number. And so we can look at another case study and how they actually put together their set of tools. This is the Rice Fergus Miller office and studio. This is another architecture firm that they did this work for themselves. And they actually started with the PV. They used the PV watts calculator to figure out how much energy they would be able to develop, that they would be able to deliver from their building site. And they used that to determine an energy budget for their building. So they said, this is what we can produce, therefore this is the amount of energy we have to work with. And so they used standard tools like Revit, and they used eQuest to do their modeling, but they integrated radiance so that they could get a really good handle on what the daylighting would be. And you can see that this is a pretty typical setup of what the analysis is going to look like. It's going to involve your standard tools, but it's probably going to involve a couple of these other specialty tools to really make this. And this is a good opportunity to mention that there is a very real difference between zero net energy modeling and code compliance modeling. When you model for code compliance, they are more concerned with the type of building and what the building is capable of. And whether that's the IACC or Appendix G or Chapter 11 out of ASHRAE 90.1, they're going to have assumptions about operations like these. This is a set of assumptions about what the plug loads are going to look like in a secondary school. And this is not what the plug loads look like in any secondary school out there. Code compliance wants to make sure that the building is capable of still being energy efficient when it's under this kind of abstract loading that covers a whole bunch of different loading scenarios. But you're looking at a specific project, a specific building, a specific set of users, a specific set of circumstances. And so this is actual measured data, again from the IDEAS office building. And you can see there's a couple of gaps in their meters there, something that happens with meters. But the kind of, I guess you might call it teal line, the bluish green one, is the plug loads. And you can see what it takes, what the plug load profile of an actual building looks like, and how there are these intermittent spikes and dips. And that is the sort of usage profile that you need to be looking at, and you need to be accounting for in your models, not some abstract set of usage, but actual usage that really corresponds to the users that will be in the building. Which brings us to our next topic. In the first two webinars, we focused very heavily on assessing, setting goals, scoping the measures, implementing the measures. But an important component of any project is actually operating the buildings. And zero net energy is the great time to talk about building operations. So while these apply specifically to zero net energy, this really applies to any project out there, especially any project that's looking to make serious gains in energy efficiency, the operation of the buildings. Because when it comes right down to it, zero net energy is an actual energy outcome. It doesn't matter how you designed the building if it's not being used in a way that actually meets the ZNE goal. So this is a sensitivity study that NBI did. We took a whole bunch of the factors that go into the energy performance of a building, and we turned the knobs on these factors, whether it's air tightness or insulation or the solar heat gain, and we made those worse and we made them better with some reasonable assumptions about what we actually see out there in real buildings. And as you'll notice, the bars where there is the biggest energy, some tremendous energy impact from turning those knobs, and you look at what those factors are, this set is highly driven by the occupants, very highly occupancy driven, which means that the operations of a building are really important to all buildings, but especially to zero net energy. And so we had this list earlier of what we called the common zero net energy technologies. But really, when you think about it, we should be talking about strategies and not just technologies, because the technologies that go into the building are important, but there are other things as well. Strategies especially for engaging the occupants and for accounting for operations. So whether that's things that can actually be built into the building, like designing the systems to normally be off and to only come on when they're needed, or something that we call programmatic zoning, where you group like uses together, where you group like schedules together, so that you can deliver those conditioning requirements only to a zone where it's actually needed, instead of delivering it to the whole building and conditioning the whole building to the highest use. And simple feedback to occupants using things like energy displays. But it also means engaging the occupants, whether that's through training the occupants or the maintenance staff. Engagement programs like this one you see here, E-Metric, which is actually an incentive program set up to improve performance, where it almost turns it into a competition. And using mechanisms like green leases to really make the operations a condition of having the tenants and the occupants in there. This is the sort of thing that can be laid out. But it can also mean more professional measures like service contracts with maintenance, employing not just design contractors, not just design build, but also design, build, maintain. Or looking at something like a resource conservation manager. You can almost think of this like your IT consultant for your building. You know, a lot of smaller businesses especially don't have their own IT staff. They hire a consultant who keeps an eye on all of their equipment and when it's time to upgrade and when something's going wrong, and they fix the little problems. And this is the sort of thing that a resource conservation manager can do with energy. Keep an eye on performance, look and see when things are going wrong, if there's a spike, see and help the owner make decisions about when it's time to upgrade, when it's time to do replacements, making sure that the maintenance happens. Because the reality is that in a lot of projects, there's this divide. We see the design team, the construction team, and a big divide, and then you see the operations and maintenance team take over. And what we really need for zero net energy is to take that operations and move that back into the design phase. But it also means bringing at least the knowledge from the design phase forward into operations, if not bringing some of the actual people from the design and construction phase forward, so that we can bridge this gap. So even if we look at this integrated project delivery model, it means that that owner team, that needs to include the operators and the occupants. On one level, that can be as simple as including occupants in the charrette process, in those early design processes, so that you know how the building is going to be used, you know how the building needs to operate, and you don't have some bad surprises once you actually hand the building over. It means controls that can actually make a big difference, and whether that's just making the controls more understandable or maybe having more powerful controls like this. This is at the DPR office, and what it actually does is this switch turns off the power to all non-essential plug loads in the building. So the last one out, turn off the plug loads, getting rid of those vampire loads that we hear about. You still have outlets that are on all the time for essential equipment like a server or something like that, or a security system, but monitors and the water cooler and other things like that that don't need to be on overnight, one switch turns them all off. And there are ways that we can make sure that those users see how the building is actually being used. This is a great standard for professionals. It's the International Performance Measurement and Verification Protocol, a way to characterize energy use so that professionals have a good idea of what the building is actually doing. But this also means designing for measurability, because getting that energy feedback to the important parties is an essential part of zero net energy. And so design for measurability means things like sub-metering and segregating the loads on the electrical circuits, getting the plug loads all together, the lighting all together, the HVAC all together, so that you can see what those loads are doing independent of each other. And so if there's a spike, you know who's responsible. Is it the lighting? Is it the HVAC? Did someone plug in a space heater? Because it's essential to have, not only have the data, but to have it in a way that makes it useful. And this means that giving feedback to the occupants themselves with tools like dashboards that turns that energy use data into something that is understandable by someone who isn't a building scientist, someone who isn't a mechanical engineer. And here's an example of a bunch of school children. So that's a great way to think about it. although maybe it should be a bunch of middle-aged people like me, because they're the ones who are going to have the hardest time with technology. But it's important to get that information to the people in a format that they can use it to adjust their behavior, so that they can see, oh, look, we're leaving the lights on, or, oh, wow, why is there so much power being used at a certain time? Because the occupants cannot adjust their behavior if they don't know the impact of their behavior. And integrating operations, therefore, whether it's something as complex as what you might have a professional do, or something as simple as what you might give to one of your occupants, it's essential in a zero-net energy building to have this feedback loop, to monitor how a building is performing. In traditional construction, the reality is that after that shakeout period of either a major renovation, retrofit, or even new construction, after that shakeout period, in most cases, that's the best that building's ever going to perform. And it's all downhill from there. And that just doesn't work with zero-net energy. With zero-net energy, you need to pay attention to the performance and keep monitoring it and keep making the adjustments, fixing things as they break, fixing behaviors as they become a problem, so that you stay within that goal of keeping your consumption within the realm of your production. Which brings us back to this idea of the process. Really, when it comes down to it, a zero-net energy, deep energy retrofit is the same process as a regular deep energy retrofit. It's still a matter of assessing the building, setting goals, scoping the measures, implementing the measures, and operating the building. But you might think of, when it comes to zero-net energy, everything becomes more intense, that you have to do a better job at each of these steps. You have to go to the full extent with each of these. You can't take the shortcuts. You really have to do every one of them to the full extent so that you can get all the way to these goals that are not as out there as they once were, but are still aggressive goals. This whole series of webinars has been supported by National Grid. And so we want to take a moment to take a look at a couple of projects that National Grid was involved in. And you can see how the utility can play a role to maybe help you get to your deep energy retrofit or your zero-net energy goals. So I'm going to hand it over to Pooja, and she can talk about a couple of projects.
Thank you, Sean. First of all, I just wanted to give a little background to everyone on the phone. National Grid has been implementing energy efficiency programs for both residential and commercial sectors for the last 20 years, and that covers new construction, gut rehabs, retrofits, tenant improvements, and so on. But today, after hearing the great presentation that Sean gave, I wanted to describe that some of our programs are designed to offer incentives, technical expertise, and training for the type of buildings that Sean was talking about earlier. The ones that Sean did cover falls under what we call the code-triggered programs, because they touch upon new construction, major renovation, tenant improvement, and end-of-life equipment replacements that do trigger the code. And in all the jurisdictions that Michael mentioned earlier, Rhode Island, Massachusetts, and New York, we offer incentives to offset the incremental costs for going that extra step in terms of energy efficiency. In addition, we also provide technical assistance. A lot of the steps that Sean mentioned earlier, we do have the technical expertise to assist project teams in getting to a point they need to for energy efficiency. The example that's on the screen right now, this is actually a deep, well, we could call it a deep energy retrofit or a gut rehab, because this was actually an existing mill building, which was an abandoned building. So there was no usage that we could benchmark it against what we're going to be making it into, which was it was going to be converted to an upscale apartment building. And we worked with the project teams in identifying what set of comprehensive measures we'll get to an energy performance that the project team was looking for. And we worked on various aspects of energy efficiency measures like heat recovery ventilation, high efficiency variable refrigerant systems, variable speed drives, high efficiency LEDs, especially for the parking garage, and also lighting in the common areas. And a comprehensive package like this resulted in huge energy savings for the customers from what they had initially decided this project to be. And we were able to offer incentives to offset some of the incremental costs through all these high efficiency measures, which was approximately 50% of their incremental costs. And in addition, we provided technical expertise as well. So we worked together with the project team in working on this gut rehab project. Next slide, Sean. This is another gut rehab project that we recently worked, and actually it's under construction right now. We worked with our energy modelers and the project owners and energy modelers in identifying 3 different scenarios with a range of what percentage they were above the code requirements. And depending upon the combination of energy efficiency measures that we picked, it resulted anywhere from 24% above the existing energy code to 42% above what the existing code required. And this consisted of a comprehensive measures including insulation, high-performance lighting, and high-performance HVAC systems. And actually, all these 3 scenarios ranged anywhere from a simple payback of a year to 3 years. The customer is still determining what pathway they want to pursue, so that is still up for discussion. But the incentive that we would offer, in addition to the technical support we offered for energy modeling, would be approximately 50% of the incremental costs. And we found that the EUIs for all these 3 scenarios range from anywhere from 51 kBTUs per square feet to 54 kBTUs per square feet. If you recall, Sean was talking about the ZP scale earlier, indicating the range of EUIs, which depends upon the project team to decide where they need to be within that EUI range. So these are just 2 recent examples of how we work with both the owner and their project team. We also provide design team incentives because we know that getting beyond what the code requires also involves more time from the design team. And so the design team incentives are designed to offer that extra incentive to the design teams to be more involved in getting together the mix of measures. I also wanted to briefly touch upon the Zero ZNE pilot. Sean's covered a whole section of ZNE and how to get to ZNE. We are currently in the process of developing a pilot program for specifically ZNE buildings. We don't have that currently worked out in terms of what this pilot is going to look like. We're going to start with Rhode Island, and then we move on to expanding this ZNE pilot to Massachusetts. So if any of you on the phone have feedback on how we should be designing this pilot, I would be happy to take recommendations at this point because we're still in the development stages of the ZNE pilot.
Great, and I think just a note of reference that the design team incentive is available in Massachusetts and Rhode Island right now, but not in New York State. Sean, can we go to the next slide, please? Okay, great. So we do have a few questions. So we have a few minutes left. Can there be, one first question is, can there be a ZNE building without a PV system?
That is one of those areas, sure, that's one of those areas where the definition of ZNE becomes an issue. And of course, there are other kinds of renewable energy other than just PV. Depending on the site that you have, you might actually have the opportunity for wind or for hydroelectric or for a biomass source for renewable energy. But there are definitions of renewable energy that don't look at just the site. Sometimes you can actually own part of a renewable energy system elsewhere. And this is the idea behind community solar or community renewable systems, where buildings actually are connected not just through the grid, but through an ownership structure to a piece of a renewable production facility somewhere else. There are also other ways that you can abstract renewable energy through things like renewable energy credits, but with each step that you take away from the site, the connection between the building and the PV becomes more degraded. And so by the time you get to RECs, I don't think there are a lot of definitions of ZNE that would accommodate RECs, but there might be. And this is one of the important things when you're targeting ZNE. You need to decide, okay, well, here's the basic idea, but what is our specific goal, especially if ZNE is being mandated for some reason, whether it's by the owner or some kind of local regulation. That you have to be able to know just how far from the site you can go with your renewables. And this can be really important. It's not just an issue of cost and getting the renewables on the project, but if you have a high-rise building, it can be really hard to get to ZNE with just on-site renewables. And these are the sorts of things that you need to be clear about ahead of time. But there are ways to bring off-site renewable energy and to connect it to your project. You just have to look out there at the opportunities and make sure that those mechanisms are acceptable for your project.
Great, thank you. Another question. What year is the national CBECS average energy usage intensity based on?
So the data is, the CBECS data is from 2000, and so that is used as the baseline for the ZEPI scale. It's a really good reference point, especially since Architecture 2030 uses it as the basis for all of their goals. It's behind the Architecture, so the Architecture 2030 Challenge, which has the Conference of Mayors is behind, and AIA, and so many organizations have used this as a benchmark starting point. So it makes a great starting point. But it's the average performance of 2000. We're going to see some new CBECS data. It's trickling out right now, but this old cadre of buildings is going to serve as this benchmark, I think, moving forward.
Great. Another question. Can a ZNE building negatively impact occupants' health in some cases?
Well, any good idea done poorly can have a negative impact on occupant health. One way that you could get to ZNE is to take all the windows out of a building, and that's going to have a negative impact on the users. You could underventilate a building, and so it's important to still continue to pay attention to the interior quality of the space and the proper functioning of the systems. But that should be part of any project. It just means that as you're cranking down on your energy performance, that you have to pay attention to these sorts of issues to make sure that you're not having a negative impact on the environmental quality of the building itself.
Great. Another question. Is an integrated project delivery team the same as a performance-based design-build team?
Oftentimes, yes. That's one way that you can get to that model. There are a lot of ways that you can put your team together. The overarching concept, though, is that you need to get all of those team members working together at the same time and getting all that feedback into the design process early. That model is one way to make that happen.
Great. Is there any estimate on how much costlier it might be to build a new ZNE building?
This is always the really...
I was at a NESE gathering recently, and there is, I know on the residential side, there's some development going up in Rhode Island now with ZNE, and I believe it's at a delivered cost of around $165 a square foot. So that's just as benchmark for residential. I don't know about commercial, Sean. Maybe you have some insight.
In commercial, ZNE is becoming more and more common, but the reality is that I don't think that we quite have the data to make blanket statements about what ZNE costs. It's going to cost different amounts in different climates and different building types. And when we're talking about existing buildings, it's going to get even more diverse because we're talking about such a wide variety of starting points, which is why that assessment is so important in the process of looking at your building and making sure that that building is a good candidate for Z&E so that the costs aren't out of control. But the reality is that the cost is coming down every year. Like I said earlier, the code is coming up, and the costs of these technologies that used to be state-of-the-art exotic technologies, exotic approaches to buildings, are making it into the mainstream, and the cost is coming down, and the commodity contractors are starting to do this stuff. So the cost is going to narrow and narrow. It's a matter of taking a look at your building and seeing where the cost is for that building.
Great. Thank you, Sean. I'm afraid we're out of time. So, Connie, if you could wrap it up. And thank you to everyone for attending today. We do have a list of the questions you've submitted, so we will be getting back to you in the next few days with those answers to those questions that we haven't addressed already. Thank you so much.